welcome. You should be on page 32 of your Algebra 1 Quarter 3 notebook. In this video, we're going to continue our journey factoring quadratic trinomials with leading coefficients of 1. So we left off talking about the diamond warm-up, and instead of drawing a diamond, I'm just going to draw a big X up here. Kind of looks like the diamond, but it's easier to draw. And then I'm going to write the standard form of my quadratic trinomial. And I'm going to tell you, we're looking for, remember, numbers that multiply to this and add to that. So this is always going to be A times C. So I'm always going to multiply A times C to get my number in the bottom when I'm looking at my trinomials. And in the top, it's always going to be B. So let's take a look. Some helpful hints for you to read if you feel it, but I'm more of a doer, so let's do some factoring. First thing you always want to look for, the GCF first. Okay, so don't forget that. If I look here, you know what? They don't all have an X, and 1 is the greatest number coefficient, so there is no GCF on that particular problem. So I'm going to draw a diamond or an X. And I'm going to think about my coefficients. I've got 1 times 12. So I'm going to put the 12 here. And then I've got a 7. So now I need to think of two numbers. I need to think of my factors of 12. I know that 1 times 12 equals 12. I know that 2 times 6 equals 12. And I know that 3 times 4 equals 12. If I look at these numbers, does 1 plus 12 equal 7? No. Does 2 times 6, 2 plus 6 equal 7? No. But 3 plus 4 equals 7. And that equals 12. There are the numbers I'm looking for. So what is this doing? By using our diamond, I am finding the two pieces of the binomials. I am trying to factor these trinomials into binomials. So I'm going to set up two parentheses for binomials. I'm going to have x's in the beginning because my leading coefficient is 1. And then this is a positive 3, so it is going to be plus 3, and that's a positive 4, and it will be plus 4. This is now factored. X plus 3 times x plus 4. If you use the FOIL method, x times x is x squared. X times 4 is 4x. 3 times x is 3x. 3x plus 4x is 7x. And 3 times 4 is 12. It does convert back. So let's take a look at number 5. First thing I'm looking for is a GCF. Well, I see that the number 2 is there. And 2 goes into 14 and 16. Can't take out an x, so my GCF is simply going to be 2. We've got to take the 2 out first. So I'm going to write 2 times x squared, because 2 divided by 2 is 1. 14 divided by 2 is 7, so 7 at minus 7x, and 16 divided by 2, minus 8. I can now set up, my big X here. I'm going to take my coefficient of 1 times C, negative 8, and we're going to put a negative 8 here in the bottom, and I'm going to place negative 7 here. Now remember, I need factors that are going to result in a negative number. So let's think about negative 1 times a positive 8. Negative 1 plus 8 is going to be a positive 7. So that's not what I'm looking for. Now, let's look at positive 1 times negative 8. 1 plus negative 8 does equal negative 7. This equals negative 8. That's what I'm looking for. So 1 and negative 8 are the two numbers I'm looking for to go into my binomials. So I'm going to take my 2 and I'm going to set up my binomials. I've got a plus 1, it's a positive 1, and a negative 8. Again, you can go through the multiplying process, multiplying these binomials, To verify that your answer is correct, then you can redistribute the 2. You will end up back at 2x squared minus 14x minus 16. Let's take a look at this. Common greatest number, greatest coefficient is 1, so no GCF there, and this does not have an x, so this has no GCF. Let's draw a nice big x. I've got 1 times 6, and coefficient, there is 1 there, it's a 1. Let's think about how do I get to 6? Well, I can do 1 times 6. Is there any way to take 1, or I could do negative 1 times negative 6. 1 plus 6 is 7. Negative 1 plus negative 6 is negative 7. These are not going to work. My next two options are 2 times 3 or negative 2 times negative 3. Well, 2 plus 3 is 5, and negative 2 plus negative 3 is negative 5. These also don't work. And those are the only factors. It's the only way I can multiply the factors of 6 and get 6. So there is no way to get these two numbers. This is an example of a prime quadratic trinomial. Let's take a look at our next example. I can see that there is no GCF. And when I draw my big X, I'm going to take 1 times 9, and my B goes in the top, negative 6. Let's think about my factors of 9. Well, there's 1 times 9. Even negative 1, I'm not going to get there. There's also, 3 times 3. 3 times 3 works. What's 3 plus 3? It's positive 6. I could do negative 3 times negative 3. That equals a positive 9. And negative 3 plus negative 3 equals negative 6. So this is what I'm looking for, a negative 3 and a negative 3. I'm now going to pull this out here. I've got set up my binomials, x, x, and both of them are negative 3. Now, do you see that these are exactly the same? Well, then it is your job to recognize that, and it's further your job to recognize that if I'm multiplying something by itself, that is squaring it. So the proper answer for this, it's a square of a binomial, x minus 3 squared. Alrighty, let's take a look at number 8. I see a common factor. I see that I can take a negative 2 out. Remember, I don't want to have that negative 1. So I'm going to have a GCF, and I'm going to take a negative 2 out. I also see that there's an x, x, and x. X is the biggest exponent, so I'm going to take 1x out. Let's see what that looks like. I'm going to take negative 2x. Negative 2 divided by negative 2 is 1. 3 minus 1 is x squared. Negative 14 divided by negative 2 is plus 7, and 2 minus 1 is x. And negative 20 divided by negative 2 is plus 10, and x minus 1 is 0, so the x goes away. Let's draw up a nice big x. I have 1 times 10, and I have a 7. I need to think of my factors of 10. Well, honestly, let's just go 5 times 2. Does 5 plus 2 equal 7? It does, and 5 times 2 equals 10. So my numbers are 5 and 2. So I'm going to take my negative 2x. I'm going to set up my two binomials. And I'm going to have a positive 5, so plus 5, and a positive 2, so plus 2. And indeed, that is now factored. All right, why don't you pause the video when I'm done here, find and correct the mistake, and you can discuss it with me since you're watching the video when you have found the mistake. What I see here is that x squared plus 2x minus 48 does not equal x plus 6x minus 8. Something is wrong with it. So pause the video, see if you can figure out what that might be. All right, welcome back. So if you draw the x, let's draw my giant x, and I'm going to take my negative 48, and I'm going to take the 2, 1 times negative 48, there's my 2, And I'm thinking about numbers, 1 times 48, 2 times 24, 3 times 16, 4 times 12. I will eventually get to 6 times 8. And really, I want it negative, so 6 times negative 8. The problem is 6 plus negative 8 equals negative 2, and I want a plus 2. So let's switch that negative. If I have negative 8, I already had negative 8, negative 6 times positive 8, that still equals negative 48. But negative 6 plus 8 equals a positive 2. So there was your mistake. This should be x minus 6, x plus 8 to get back to that trinomial. Alrighty, we're going to go to page 33, and we are going to take a look at factoring some quotients. And I want you to know that you're not going to be doing a lot of anything different. We're just going to be factoring the numerator to see if we can cancel out this denominator. So there's no GCF here in x squared plus 9x minus 36. So 1 times negative 36 is negative 36, and 9 is up here in the top. And I want to think about what numbers go into 36. Well, I've got 1 times 36. I know that's not going to work. 2 times 18, that's not going to get me to 9 on any level. 3 times 12, if I had a minus 12 times 3, well, minus 12 plus 3 is a negative 9. So let's do a 12 times negative 3. That equals negative 36. And 12 plus negative 3 equals a positive 9. So those are my numbers. I need a 12 and a minus 3. So in my numerator, when I set up my binomials, I'm going to notice I have a plus 12 and a minus 3. And look at that. If I have a number divided by itself, or a binomial divided by itself, that cancels, and my answer is going to be this solitary binomial x plus 12. So x squared plus 9x minus 36 divided by x minus 3 equals x plus 12. This is finding the quotient. Just remember, quotient is division. So I'm looking for the quotient of 2x minus 4x minus 32x squared over x minus 5. So first of all, my GCF looks like it's going to be 2. So I need to take 2. 2 divided by 2 is x squared. Negative 4 divided by 2 is negative 2x. And negative 30 divided by 2 is minus 15. And it's all going to be over x minus 5. Now, if we draw our nice big happy x, I've got 1 times negative 15, and I've got a negative 2. Thinking about my factors here, and I know that 5 times 3 equals 15, but if I need it to be negative and I need that to be negative, I'm going to have my negative 5, my 5 be the negative, because I want my answer when I add them to be negative 2. So I want negative 5 and 3. So now I have 2 times x minus 5, x plus 3, all over x minus 5. We can see we've got these binomials canceling, and this is all that is left. So my answer is 2 times x plus 3. And that's all for this video. Thank you so much.